In stats, we can make a mistake. Those are called type 1 and type 2 errors. So this is when we make a conclusion. We decide whether or not we're going to reject the null hypothesis or fail to reject the null hypothesis. But actually, we did the wrong thing. Now, it's not that we did the wrong thing based on, like, we just kind of made a rogue decision. It's that we had data that made us make this decision. But for some reason, our data was maybe skewed or whatever it could have been. So there are two kinds of mistakes that we might make. They are type 1. A type 1 error is when we reject the null hypothesis, but should not have. Now, this only happens when the p-value is less than the significance level of alpha. Because when the p-value is low, what do? You reject the hoe. So if the p-value is lower than the alpha value and you reject the null hypothesis, there is a chance that you are rejecting the null hypothesis incorrectly, meaning that you've rejected it, but really you shouldn't have because it was actually okay. It was actually true. The claim was actually right. So that's a type 1 error. A type 2 error, this is when we fail to, notice how I wrote to, fail to reject the null hypothesis, but should have. We should have rejected. So the only reason I write the 2 in this way is just to help me remember and help you remember that a type 2 error occurs when we fail to reject the null hypothesis. It's not like you have to write it that way. It's just kind of a visual to help you remember which one is which. This can only happens when the p-value is greater than or equal to the alpha value, because that's when you're going to fail to reject. So here's the deal, you guys. If you reject the null hypothesis, there's no possibility of making a type 2 error because they don't go together. So only when you reject the null hypothesis can you make a type 1 error. And only when you fail to reject the null hypothesis can you make a type 2 error. Those are the only ways you can make these errors. They don't cross. So we've got a little chart to help you guys kind of see this. Now, when we have somebody on trial, I know that the jury can only say that they're guilty or not guilty based on the evidence, but in reality, they're either innocent, they didn't do it, or they're guilty, and they did it. That's the reality. In our actual data, our null hypothesis is either true, even though we're not going to accept it because we don't accept hoes, right? Yeah. All right. So either our null hypothesis is true or the alternative is true. But our decision based on the evidence is that we're either going to reject the null hypothesis or fail to reject the null hypothesis. So when we do this, some things can happen. Let's say we reject that null hypothesis in favor of the alternative. We reject the null hypothesis in favor of the alternative, and the null hypothesis was actually true. What has happened? This is the type 1 error. Now, we actually know exactly what our probability of this happening is. The probability that we commit a type 1 error is equivalent to the significance level. Most significance levels are 5%. Okay, most significance levels are 5%. So what we're basically saying is we are okay with there being a 5% chance of us rejecting the null hypothesis even when we shouldn't have. We're okay with 5%. If you have a situation where a type 1 error has really big consequences, we'll talk about consequences here in a minute. If you have a situation where the consequence of this happening is really big, then you're going to want to make your significance level smaller. Makes it harder to prove the alternative. You got to get a really low p-value. Okay? So if we have a situation where we want to make sure we don't make a type 1 error, then we're going to minimize alpha to make sure of that. All right, let's say we reject the null hypothesis in favor of the alternative, and the alternative is true. What have we done? We have done a good job. We have done an actual great job. We have rejected the null hypothesis in favor of the true alternative. Let's go. What if we fail to reject the null hypothesis? So we're sticking with the null hypothesis, and the null hypothesis is what is true. What have we done?
Good.
Good job. You did not reject. Why am I trying to say reflect? Whatever. You did not reject the true null hypothesis. Good job. All right. Obviously, you guys know this last square. If you fail to reject the null hypothesis and the alternative is what was actually true, what have you done?
Bad.
That's bad. This is a type 2 error. Guess what? There's a probability of this happening. Now, we're not going to talk a lot about this particular probability for a while, but just FYI for future reference. Alpha is the first letter of the Greek alphabet, right? Alpha, type 1 error. That's cool. Any ideas what the probability of a type 2 error might be? Beta. Beta looks like a really fancy capital B. Beta looks like a really fancy capital B. Again, we don't use this very often and we won't use it for a while. It's just, I just wanted you guys to know that. All right, cool. You guys remember the example yesterday about Officer Trainum and his little speed sensors? Yeah. All right, yeah, right? So we're going to kind of recycle with that question. So again, in our previous example, he wanted to determine if it was worth the cost to install speed sensors. All right, Officer Trainum will select a random sample of 100 cars and perform a significance test with alpha equals 0.05. By the way, if alpha is 0.05, what's the probability of a type 1 error occurring? 0.05. Okay. All right. Describe a type 1 and a type 2 error in this setting. All right, type 1. Now, I know that you just wrote this down, but I do this every time, even when I'm doing my own little thing. So, type 1 is when I reject the null hypothesis, but should not have. I always write that down just to keep it straight, because it does start to get a little like, wait, what am I doing here? Okay, if I have rejected the null hypothesis, then I have said that P is greater than 0.2, but it's really not. Okay, so this is when I say P is greater than 0.2, but it really is not. All right, consequence of this. So what? Who cares, right? Well, let's see who cares. If we say that P is greater than 0.2, and we submit that to the McKinney PD, what are they going to do? They're going to install some sensors. But did we need them? No. We have wasted McKinney PD money. Wasted money and equipment. Is that bad? Yeah, that's pretty bad, you guys. We're so sad. We could have built like another fire station number 487. All right, type 2. This is when you fail to reject the null hypothesis, but should have rejected. So we do not reject the null hypothesis, but we should have. So what does that mean? We don't say that P is greater than 0.2, but it really was. So this is where we do not say P is greater than 0.2, but it really was. Consequence. So what? Who cares? Whoop-de-doo. Children are dying. All right, yes. I mean, no, sad. So sad, right? So in this situation, we don't get the speed sensors, but we need them. We could have saved some lives, right? So we have an unsafe school zone continues. Yikes. Here's the big question, you guys. Which one's worse?
Wasted money.
The first one.
Wasted money or dead children?
Wasted money.
It's all about the profits.
When you put it that way. I would argue that it kind of depends. It depends. Are you the manager of the equipment and the money and you're about to get fired now? Or are you the kid that just got run over by a speeder? It kind of really depends, right? So there's really never a right or wrong answer to that. It's kind of like, what's worse, being an innocent person in jail or being a guilty person walking free? What's worse? It depends on your perspective. Are you the innocent person sitting in jail for someone else's crime? Or are you the innocent person who gets killed by the murderer that got off from his crime? It depends, right? So there's never really a right answer to that, just so you know. All right, significance level in type 1 error. I've already said this, but I'm going to just make a very big point of it right here. The probability of a type 1 error is legit equal to the significance level. It's literally that easy. If you know the significance level, then you know the probability of a type 1 error occurring. Keep in mind that alpha is the first letter of Greek alphabet. And that's how I keep it straight, that alpha is the probability of a type 1 error. Type 1 error. So just try to keep that in mind to help you remember what's happening here. All right, so back to this example one more time. Previous example, same situation. All right, but here's the difference. Suppose that the police commissioner decides to carry out his own test using a random sample of 250 cars and a significance level of alpha equals 0.1. What is the probability that the police commissioner will commit a type 1 error? The probability of a type 1 is equal to the significance level, which in this problem is just 0.1. Ladies and gentlemen, there's a question like that on the test.
Yeah.
Would you be shocked that a lot of people miss them?
Yeah.
We have?
People miss this, not the test you're going to take. Yeah, past people have missed this. Why? Because there's all those fancy looking words up there and all that fancy looking notation, and they make it harder than it is. It's okay. Sometimes stats is easy, you guys. Sometimes it's just like that. All right, cool. Last example. Fast food. Guys like fast food? No, you hate it? The manager of a fast food restaurant wants to reduce the proportion of drive-through customers who have to wait longer than 2 minutes to receive their food after placing an order. They must be working at Chick-fil-A. Based on store records, the proportion of customers who had to wait longer than 2 minutes was 0.63. So 63% of their customers are having to wait longer than 2 minutes. To reduce this proportion, the manager assigns an additional employee to the drive-through orders. During the next month, the manager collects a random sample of 250 drive-through times and finds that the sample proportion, P hat, is 144 over 250, which is 57.6%. Time out! Does it appear that this new employee made a difference? If the original proportion that had to wait longer than 2 minutes was 63%, and our sample proportion after adding this new employee is 57.6%, does it appear that they made a difference?
Yes.
It looks that way. But was it statistically significant and we should keep them on? Or was it just sampling variability from the sample? So we don't know. That's why we go forth and do the test. The manager performs a significance test at the alpha equals 0.1 significance level. Time out. What's the probability of a type 1 error? 0.1. Okay, cool. The null hypothesis is that the proportion that have to wait more than 2 minutes is still 0.63. It's not changing. The alternative, what we hope, is that this employee helped and now the proportion is less than 0.63. P is the true proportion of drive-through customers who have to wait longer than 2 minutes. They do the significance test, we get this p-value. P-value is 0.0385. Interpret the p-value. Assuming the null hypothesis of p equals 0.63 is true. Remember, we always assume the claim is true unless we prove it otherwise with our significance test. Assuming that that is true, there is a 0.0385 chance of getting a sample proportion as extreme or more extreme than 0.576. Assuming that we are truly on a 63% distribution, there is only about 4% chance that this sample of 57.6% happened by sampling variability. There's only a 4% chance that that result was sampling variability. You know what that means? That means there's a 96% chance that we made an actual difference with the new drive-thru employee. Does it sound like the drive-thru employee made a difference?
Yeah.
It does. There's a 4% chance that this sample was just from sampling variability in this 63% distribution. But there's a 96, the complement, a 96% chance that this employee made a true difference. Okay? Okay, that's what that means. Type 1, type 2 error, let's go. A type 1 error. This is when we reject the null hypothesis, but should not have. Okay, so let's think about what that means here. If we reject the null hypothesis, that means that we said that the proportion was less than 0.63, but it really was not. So this is us, we say P is less than 0.63, but it really is not. Uh-oh. What's the consequence of that? If we say the proportion is truly now less than 0.63, what's going to happen with the employee? If we say the proportion that have to wait longer than 2 minutes has gone down, what happens with the employee? We're going to keep him, right? But the proportion really wasn't low. So what are we doing now? We're paying an unnecessary, we're paying a useless employee.
Trash.
So the consequence here is we keep a useless employee. Now that's pretty sad, isn't it? Unless you're the useless employee that's getting paid to do a lot of nothing. But that's kind of sad. All right, what's type 2? Type 2 error. This is when we fail to reject the null hypothesis, but should have rejected Okay, so in this situation, what have we said about the alternative? We don't say that P is less than 0.63, but it really was. So this is when we do not say P is less than 0.63, but it really was. All right. If we don't conclude that the proportion went down, then what happens with the employee? We're going to get rid of them, but the proportion actually did go down. So should we have gotten rid of them? No. We fired a good employee, you guys. The consequence here is we fired a good employee. Sadness. So which one's worse? Keeping a useless employee or firing a good one?
character in all cases. It never depends. For one.
Oh, it doesn't depend?
Yeah, it's the only right answer.
Is it?
Yeah,
Really? Are you
Yeah.
sure?
I'm sure.
Oh, okay. Cool. I think it depends. If you're the manager of this place and you're paying somebody who's standing around twiddling their thumbs, like, that kind of stinks. Kind of stinks for you. Oh. All right, what conclusion would we make with this significance level? So we had a p-value of 0.0385. That is less than the significance level of 10%. And what do we do when the p-value is low? We're going to reject the null hypothesis. Why can we reject the null hypothesis? It's because there is convincing evidence that P is less than 0.63. We have convincing evidence for our alternative. Now, time out. If we have just rejected the null hypothesis, what error might we have made? We might have made a type 1 error. Okay? Oh, sorry. Since we have rejected the null hypothesis down here, based on our p-value, then we may have made a type 1 error. Okay. Questions, comments, concerns?